Let's see. Test 17B, otherwise known as the review. I'm going to get through as much of this as I can. I may have to do this in two parts. I'm going to trust that you have the document sitting in front of you. I'm not going to go back and forth between the document. I'll try to draw as much on each slide as I can. I'll send this document out to you when it's all done, as well as the video. So you can take a look at that. Question number 1 says the price of the hamburger meat varied linearly with the weight of the package. If a package of hamburger meat weighed 5 pounds, the price was $8.45. So we got $8. $8.45 equals, let's see, the M5 plus B. And in our second one, it was 2 pounds. And our price was like $3.38. All right, from here, what we're going to do is we're going to cancel out B so we can solve for M. So we're going to subtract those two things. Let's see, that's going to be 3M. I'm going to use my calculator rather than pulling one up on the board because I think you guys can do this. 8.45 minus 3.38. I get 5.07. We're going to divide by 3. Okay, divided by 3. Okay, M equals $1.69. So essentially what we're saying there is it's $1.69 a pound. The last part of this question, let's see, how much would a 10-pound package of hamburger meat cost? That's pretty much all we're asking. But we do need to find B, so we're not quite done yet. Let's go ahead and take 8.45 equals $1.69 times 5 plus B and solve for that. $1.69 times 5 is, let's see, hold on. Okay, looks like $8.45. Would subtract, so it looks like B equals 0. I'm going to check some things here, make sure that we're on the right track. B does in fact equal 0. Alright, which means our equation is y equals 1.69x, no B. So basically, the last part of this question says, how much would a 10-pound package cost? So we just need to take 1.69 times 10. So the cost is $16.90. Okay, $16.90. Checking our answer here, that is it. Okay, move quickly on to question number 2. Okay, it says Aaron traveled J inches in T seconds. And then traveled K inches in 4t minus 2 seconds. So let's start off with distance, rate, time. Okay, he starts off here, he travels J inches in T seconds. Okay, rate is distance over time, so that would be J over T in case we need that. Let's see, we'll call that D1, R1, T1. We talk about D2. D2 is 14 minus, let's see, then he traveled K inches. Okay. T2. Let's see, in 14 minus 2 seconds. 14 minus 2 seconds. Let's make sure we can see the difference there. 14 minus 2. R2 is K over 4t minus 2. All right. At his average rate, how long would it take him to travel 10 inches? Okay. at his average rate. Okay, well, average rate, overall average rate, let's find out what that would be. Overall average rate is overall distance over overall time. So that would be t plus 4t minus 2. So we can simplify that to j plus k over 5t minus 2. This is our overall average rate. Now, that's not the end of our question. The question is how long? How long would it take him to travel 10 inches? Okay, well, it's a matter of time. Time is distance over rate. So distance being 10 inches, okay, over 1 divided by j plus k over 5t minus 2 means we would cross multiply, or not cross multiply, but multiply by the reciprocal. So our final answer, we're going to distribute the 10 to the 5t minus 2, which would be 50t minus 20. And then j plus k times over 1, so over j plus k. And let's see, our question is in seconds. Let's see if our answer is right. 50t minus 20 over j plus k seconds. That's our answer. All right, number 3. Number 3. Find antilog. Okay, so we got 5, 2, I think is 1, and then the other one is antilog. Let's see, is it 9, base 9, 3? All right, so this becomes this, which should just be 25. This should become this, which is a little bit more. 9 to the third is 729. Let's check our answers there. On 3, 25, and 729 are correct. Okay, that definitely would be on my list of questions I'm going to do. All right, no more work than that takes. Okay, number 4. Trying to get as much done before I have to do morning duty. Number 4. Let's see, we've got dx plus cy equals f, and gx plus hy equals j. What do they want me to solve for? They want me to solve for y. Okay, they want me to solve for y. All right, if I want to solve for y, what I'm going to do is I'm going to eliminate my x's. So I'm going to multiply by g here and by d here. Now this is different than how, say, Samir is going to do this. Should still come out to the same answer. So I'm going to rewrite this as g dx plus g cy equals gf, and g dx plus d hy equals dj. Then what I'm going to do is I'm going to subtract, which is going to eliminate all of that. I'm going to get gcy minus dhy equals gf minus dj. Okay? Because we're solving for y, I'm going to look at my left-hand side. I'm going to factor out y. So I'm getting y on the outside, gc minus dh equals gf minus dj. And then finally what I'm going to do is I'm going to divide that out. gc minus dh over gc minus dh. And this should be our answer. We'll check it. Number 4, DJ. DJ minus FG is their answer, which basically it's going to end up being the same answer if we had multiplied by -1, for instance. We would get that same thing over DH minus CG. Mine's just reversed, so it's just, yeah, it's an equivalent answer, so there's nothing wrong there. So yeah, that's acceptable. All right, number 5. Number 5. It says use the result from problem 4 to solve for y. We really don't need to do that. We're just going to solve for 5 the same way we solved for 4. We're going to solve for y again. This has 9x plus y equals 6. And x plus y equals 10. Okay, now in this one, again, they want us to solve for y. And like in most of these, there's several different ways to do this. I'm just going to try to stay consistent with how we did the other one. I would multiply this part down here by 9. So I would get that 9x plus y equals 6. And down here I'd get 9x plus 9y equals 90. All right, and if I wanted to subtract, which I could do, okay, these would now cancel out. I'd get 1y minus 9y, which would be negative 8y. And 6 minus 90 should be negative 84. Divide by negative 8. Y should equal negative 84 divided by negative 8. I get 5. Let's check our answer for 5. Let's see, they got 84 over 8, which is 21 over 2, which is the same as 10.5. So either one of these would work. Even if you wanted to put 84 over 8, we'd accept that too. All right, number 6. Number 6, sketch the graph of y equals log base 2x. Let's see, we'll just take a look at that from here. Where's my guy at? Clear some of this work out. All right, so for this, I'm actually going to have to rewrite it because I've got an older calculator. I'm going to have to plug this in as log x divided by log 2 in order to get an actual graph. Okay, so I've got to come in here, log x, close parentheses, divided by, parentheses, log 2, close parentheses, graph. All right, so we're going to have probably a fairly basic graph. Looks like it came down to about -2. I did something like that. Let's pull this guy back up and let's see if we can get a table of values out of it. Okay, so it's actually, we're going to include at least the first couple points. So it does cross exactly 1, so we got what? X, Y, we got 1, 0. Let's see, let's pull that back up. 1, 0, 2, 1. And then 3 was like 1.585. That's probably going to be enough for me. That's pretty specific. Okay, 2, 1, you know, we're seeing some points here, get a point here, okay, those types of things. And here, everything above, everything less than 1 on the x was error, which means it went down into infinity. Okay, so what I'd like to see here is that. Okay, let's see if they give much in terms of the answer. Yeah, they give 2 coordinate positions in a graph on 6, 7, 7. Okay, we've got convert 4 minus 3i to polar coordinates. Okay, 4 minus 3i. This is to polar coordinates. Polar coordinates include the hypotenuse and the angle. So if I'm doing this, 4 minus 3i, that means I'm going to go 4 to the right, 3 down. So I should get something like this. Okay, we're at 4, okay, negative 3i. The handy thing about this is that the hypotenuse here is really easy to figure out. Because it's a Pythagorean triple, I know that my hypotenuse is 5, right? 4 squared plus 3 squared equals c squared. We've got 16 plus 9, which is 25. Square root of 25, c equals 5. Okay, that guy goes right there. We do still have to find this angle, though. Okay, let's see, I'm going to look at what exactly they're going to look for on this. On 7, yeah, that's kind of what I thought. All right, so we're going to need our calculator here. We're going to do, I'm going to use the values that they give me, which is opposite over adjacent. So I'm going to use inverse tangent. Okay, negative 3 over 4. Okay, let's see what we get. Hopefully we get something that's going to look right. Let's see. Okay, inverse tangent, because we want an angle. Negative 3 divided by 4. Yep. Negative 36. Okay. 0.8, I want to say 7. Negative 36.87 degrees. We'll pull it up again just to double check that our calculator came out to basically the same thing. Okay, so that's, okay, that gives us everything for A. All right, let's look at B, 7B. It says convert 9 cis 300 to rectangular coordinates. All right, let's put 9 cis 300 to rectangular coordinates. Okay, so what we're saying here is that we're at 300 degrees going this way, which is going to bring us 60 degrees here, 30 with a 9. Okay, so we've got a y value and we've got an x value, and we're looking for the rectangular coordinates. If I want my x value, I'm going to end up doing, give me a second here. It should be 9, my hypotenuse 9 cosine 60. Okay, because essentially what we're doing is we're using the reference angle. So we're using cosine 60 equals, let's see, it'd be x adjacent over 9. So that's why we're using ultimately 9 sine 60. So we can see what 9 sine 60 is. Nine cosine 60. Okay, we get 4.5. Okay, which they're going to actually prefer 9/2. Okay, and we could honestly, I should have looked at this, but because it's a 30, 60, 90, we can actually do a lot of this without, any kind of graphing calculator here. But just so we're familiar, to get the y, we would do 9 sine 60. Okay, the problem is that that's going to end up, because it's a 30, 60, 90, we're going to end up with a radical. So we're going to get 9/2, and then we're going to get 9 radical 3 over 2, just because of it being the 60 side. So because that comes out the way that it does, we're going to write this as 9/2, and because that's minus, we're going to get 9 radical 3 over 2i. Okay, to get our rectangular coordinates. Let's check that. 9/2 minus 9 radical 3 over 2i. Okay, so this is my answer for B. Okay, this was my answer for A, as well as the work. Okay, we're at number 8. Number 8. Let's see. This looks like it's an angular momentum. The wheels of Kim's car had a diameter of 36 inches. You want to make note of the word diameter there. If she was traveling at 40 miles per hour, what was the angular velocity of the wheels in radians per minute? So our natural form is linear velocity equals angular velocity times radius. But as I take this question and look at it again, we know the diameter is 36 inches, so let's, but what they're looking for here is they're going to ask for the angular velocity. So actually I have to solve for angular velocity, which means we're going to divide by r. So v divided by r equals angular velocity, or better yet, angular velocity equals v over r. Okay? So just so we see the difference there. Okay. So our linear velocity, our linear velocity was 40 miles per hour. Okay, 40 miles per 1 hour. Okay, divided by, we had a diameter radius of, we had a diameter of 36 inches, which means we've got an 18-inch radius. Okay. All right, and we have angular velocity for this. All right, give me a second here. We're going to end up rewriting this this way. Let's see. Is miles 40 over 18. Okay, 40 over 18 is miles per hour inches. Okay, and we want our answer in, okay, what was the angular velocity of the wheels in radians per minute? Okay, per minute, radians per minute. Okay. And because we're not, you'll notice that we were 18-inch radius and we're in 40 miles, we've got to get all of our distance units the same. So we're going to end up converting, we're going to convert our inches to miles, and we're going to convert our hours to minutes. Okay. Okay. Let's see. First things first, we're going to convert our inches into feet. So we've got 12 inches, 1 foot. Next thing we're going to do is convert our feet to miles. Feet to miles. 5 to 81. Next thing on the list is to convert our hours to minutes. Okay, down here. Okay, we got our hours, our minutes, 1 hour, 60 minutes. And that's it. That's there's nothing else besides just to do it. So essentially down here we have 40 times 12 times 5,280 divided by 18 times 60. Don't think that there's anything else there. All right. So that's what's going to give us our radians per minute. Okay, so our final decimal answer on this. Okay, 40 times 12 times 5,280. Close up my parentheses here so I can do everything at once. 18 times 60. Okay, and we're gonna take this to the to 2 decimal places. 2346.67. Okay, radians per minute. Okay. All right, that's number 8. Number 9. Number 9, find the range, mean, median, mode, variance, and standard deviation of the following data: 5, 10, 14, 9, 10, and 6. I'm just simply going to give you the answer here because what you're going to do is you're just going to plug it in your calculator. Let's see, let's look at this. Your range, okay, which was 14 minus 5 equals 9. Your mean, you would have added all that up and divided by how many there was 9. Your median, which you just look in your data there, you're going to scroll down to the bottom, you should see 9.5. Your mode, you can just look and see which ones repeat, and you should see 10. Your standard deviation, okay, or let's see, it was probably SX, wasn't it? Sigma. Is 2.94. And in your variance, which is 2.94 squared, is 8.67. That's your answer for 10. Again, this is definitely one I would do because it doesn't require that much work, time, or ability. Number 10. Number 10. Okay. Number 10 comes into 2 parts. Okay, we got an A, which we'll do first. You should be able to look at your graph. It says on these, write the equation of part A as a sine function and part B as a cosine function. The nice thing about part A is that it already appears to be a sine function, and part B already appears to be a cosine function. So there doesn't appear to be any kind of phase shift there. Or, yeah, there's no phase shift. There is a period change. So let's go through center line. Center line on A, it's between 6 and negative 8. So 6 plus negative 8 divided by 1. Or sorry, divided by 2 is negative 1. So it shows 1 there, and it does look like a negative 1, but I just wanted to be sure. So our center line is negative 1. Our amplitude, we're going down from there. We're going down from negative 1 to negative 8 as we cross through. So we should have an amplitude of -7. Okay, our function is sine, or our function value is theta. Okay, from here, we want to check a period change. Okay, it completes its cycle in 180 degrees. Okay, which means it's going to complete 2 cycles in 360 degrees. So our period change is 2, and our phase shift is, not applicable because there's nothing there. All right, so the equation we should write is y equals -1 minus 7 sine 2 theta. All right, let's check our answer key. See if we get that on 10a, -1 minus 7 sine 2 theta. Perfect, we got that one. Okay, let's look at our next one, B. Okay, center line, we got 20 and 2. So 20 plus 2 divided by 2 gives us a center line of 11, which they show me. Amplitude, again, also appears to be negative from 11 to 2. Okay, so 11 looks like that would be -9. Okay, our function is cosine, and the value that they're using there is theta. Okay, period change. Okay, comes through at 0, goes to 120 degrees. 120 degrees. So what we're going to do is we're going to take, like in our other one, where it crossed at 180, that's pretty easy to figure out. It's going to go through another period and another 180 degrees in B2. What we would do there for the math is we take 360 divided by 2 and it'd give me 180. Or 360, better yet, 360 divided by 180 gives me 2. So what we're going to do here is we're going to do 360 degrees divided by 1. And it's 3. Okay, so we'll go through 3 periods. So we're at 3 there. It appears that in my phase shift, that's not really needed. So we should get y equals 11 minus 9 cosine 3 theta. Let's check our answer key. See if we're on the right track. Y equals 11 minus cosine 3 theta. That's my answer right there. And I really feel like these are actually pretty easy because there's no phase shift, so there's no real worry about the rest of that. So you only have a few things you need to find there. Number 11. Okay, number 11. We got about 12 minutes left here, so we'll try to get as much done as we can. All right, I'm going to take this one, write it up. This is an actually fairly easy question. It looks really hard. So 7 log 7, this needs to be a base. Log 7, 4 minus 2 log 7, 2 plus 3 log 3, 5 plus log 3, 2 minus 2 ln e cubed. Okay. It may be more complicated than I made it out to be, but all right. First thing that I would do is I'm going to move this 2 up here. Okay, so essentially what we're saying is that this becomes 4 divided by 4, and because it's all log base 7, everything else goes away, the logs drop off. This whole section here becomes 1. Okay, the answer to that is 1. If I come over here, I've got 3 times 2. Or sorry, not 3, but 5 times 2. 5 times 2 is going to be 10. Okay, 5 times 2 is 10. So we're going to put plus 10. So this whole thing right here simplifies to that. Okay, most people, I think, hopefully we're not too bad at being able to do that. So this is 5 times 2. Okay, came out to that 10. And then we get to this next part, which is this minus 2. Okay, so from here, what we're actually going to do is we're going to take this 3 and we're going to move it back out front. So because ln e is equal to 1, what we get here is negative 2 times 3. Okay, because ln e equals 1. So this whole section here, okay, is negative 6. Negative 6. So minus 6, okay, is this guy. So what we wind up with in the end is 1 plus 10 minus 6. 11 minus 6 is 5. That's our answer. It looks hard, it's really not too bad. Number 12. Number 12. Okay, so we got 4 cis. Okay, so we have polar coordinates. 4 cis, negative 20, times 5 cis 170. 5 cis 170 degrees. So we multiply our hypotenuses to get 20. And then we're going to add our degrees. So what we should get is 150 degrees. And what are they asking for here? Express your answer in rectangular coordinates. Give an exact answer, which means what they want is they want it in, they want it simplified radical. So looking through here, 150 degrees. It's going to be there with 30 degrees, 30, 60, 90, hypotenuse of 20, which means we follow our rules. So I'm going to divide by 2 to get 10, and then I'm going to get 10 radical 3. I'm going to keep in mind that that's negative, so my final answer should be 10 minus 10 radical 3 I. Let's check our answer. On 12. Oh, let's see. Oh, I understand my mistake, because our x-coordinate has to go first. Negative 10 radical 3 plus 10I. Okay, make sure you're careful with that. Negative 10 radical 3 plus 10I is our answer. X, then Y. 13. Okay, 13. Graph the solution system of inequalities. I'll go ahead and write these down. And you see different parts of this. Okay, so we got Y is greater than or equal to x minus 1 squared plus 3. Okay, so that's a parabola. And then we have y is less than or equal to x plus 4, which is a line. Okay, so we've seen these. I've seen this question before. Okay. Okay, we'll start with that. All right, so on this guy right here, it's going to open upwards because this is positive. The coordinates of the vertex are going to be to the right 1, up 3. So to the right 1, 1, 2, 3, about right there. And we're going to open up, okay, from there. Okay, let's see, and we want greater than, which means we're going to shade inside. Okay, for this next part, we want to graph our line, which has a y-intercept of 4. 1, 2, 3, 4. So it looks like that. And it goes up 1 over 1. So here, 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 you know, kind of so on and so forth. There. Okay, so, and it's solid, okay, and it says y is less than. So what we should see, if I'm not wrong here, is we should see this shaded region there. Okay. And that looks to be pretty accurate. Yep, that looks good. Okay. But our graph does need to be specific. So your vertex has to be in the right spot. It's got to open up, and then your line has to have the right y-intercept, and it has to have the right slope. Okay, everything needs to work there. Okay, so you want to be real specific about your graph. Okay. 14. Okay, 14. Okay, so we need to take this equation and then complete the square in order to get the equation of a circle. So they give me x squared plus y squared minus 8x plus 6y plus 15 equals 0. This may be the last one I do before I have to cut it short. We're going to put our x's together, so x squared minus 8x, y squared plus 6y, and this is going to equal negative 16 over here, so we're going to move that. Okay, we're going to take our negative 8 divided by 2 and square it. We want to take our 6 divided by 2 and square it. So we can rewrite this as x squared minus 8x. Negative 8 divided by 2 is negative 4. Negative 4 squared is positive 16. Okay, we're going to add, so we've got negative 16 plus 16. Okay, and over here, we're going to have y squared plus 6y. 6 divided by 2 is 3. 3 times 3 is 9, so plus 9 plus 9. So you'll notice that our 9s are going to cancel out there. We'll get that 9. This becomes, you know, x minus 4 squared is going to be that, plus y plus 3 squared equals 9. So in the end, our center is 4, negative 3, with a radius of 3. And let's check and see what they're looking for there. Make sure 4, negative 3, radius 3. So this is our answer. Okay. Let's see. Probably that's as far as I can make it for now. I'll have to finish up the rest of this probably on my planning period. And so let's hit stop and I'll finish that then.